Hello. Hello. I'm doing another virtual contest today. This time I'm doing Atcoder Grand Contest 50. If you don't know, the Atcoder Grand Contest are notoriously hard. I picked one that I hoped wasn't like impossible, but we'll see how that goes. Starts in 25 seconds. 25, 24, 23. I'm ready. Yes, I'm ready. Can't do much now. 10 seconds. Hopefully I don't fail. But based on yesterday's contest, failing's probably gonna happen. And I get to start. It does not take me to tasks immediately. Okay, come on. Hurry up and load. Alright, looking at the first task. It is Atcoder Jumper. Here, the numbers are carefully chosen so that we can jump from any page to any page in a small number of steps. Okay? 2 links on each page. Two links on page I, a link to page AI, and a link to page BI. You must be able to jump from any page to any other page by clicking at most 10 links. Okay. Well, immediately I see that 10 is like log n, so I'm thinking of construction. So, just to be clear about the problem, basically, I need to fix this first. Okay. What's it? Not this. Shoot. Okay, there we go. So you have an array, right? Like something like this. Well, think of it as like nodes, I guess, of graph. And you'll have 2 outgoing edges from one edge to 2 other nodes of your choice. Something like this. So as you can see, each one has 2 outgoing edges. And then you need to get from one node to any other node in at most 10 jumps. So I'm guessing it's some sort of something to do with powers of 2. So let's see. Let's imagine you're starting from node 1. I'm going to put all jumps that are of distance power of 2. 1, 2, 4, etc. Now, to be able to get one distance from the other in log n jumps, well, imagine, oh wait, well, of course, you can only have 2 outgoing nodes. Oh wait, I didn't start my music. Okay, there we go. Alright. This is definitely tricky. So what are my ideas? I guess let's sorta try making some constructions of the small n, and then we'll see how to go from there. So for 3, let's think about 3. Well, I guess that's not very helpful. Because like for small cases, it's easy. You can just sort of add them naively. first off, let's say you do two things. You add a node, you add an edge, one edge to the node directly in front, and then the last one wraps around. If we assume that we start with this, can we add one extra edge from each node to satisfy the constraint? Let me add more nodes to my picture. So let's add some nodes, add some edges, so you can go in like a circular path. Say from node 1, so we want to connect to the middle node, let's say. Be able to jump from any page to any other page. Alright, so node 1, say this goes to the middle node. Let's say the middle node, and then goes to node 1. Now, what does that mean? That means if we go from, we split the range in half, right? Now any node can go to either, if they need to go all the way around in a loop, they only have to get to first node 1, then they can jump halfway. Oh no, maybe this loop idea isn't super great. Two links, link to page A and link to page B. Let's just care about getting node 1 to every other node and 10 links. What would that look like? Well, we'd probably want to do this. And then we'd want to send this one halfway. Alright, so it looked like a typical sort of like, binary search or segment tree, divide and conquer, whatever you want to call it. So, except you would be taken off first. Hopefully you see what I'm doing. I'm trying to create like jumps, size, power of 2. Here. And then inside of the range, you keep it also as powers of 2. Sure I'm liking this idea super well. But I guess let's kind of continue forward with it. need to go to the other side. Jump along here. Otherwise, you go forward by 1. How many steps will it take, worst case, to get anywhere? Well, basically, every step that you don't jump a power of 2, you jump by 1. So, for every distance, let's call the distance x, you need some value you need to find some value y that has a z bit set. So x is equal to y plus z. Why? Think about the binary representation of y. Let's say it has 4 bits, like this. Oh wait, no. Z is the number of bits not set. So every time that there is a 1 in y, you're going to take the power of 2. However, when it's a 0, you move forward by 1. So that's why it's like x needs to be in the form of y plus z. Is it always possible to compose x like this? I think so. I'm not 100%. Well, yeah. I think with 10, it's lenient enough where you can add a few extra spaces if really need be. Alright. So then, this construction works only for from node 1 to other nodes in login steps. However, what if you start halfway through here? How are you going to get out in time? Well, think about it like yet again, like a segment tree. There should be some middle node that you're like doing powers of 2 backwards, and also you're doing powers of 2 forward. And we don't have to construct the paths ourselves. All we have to do is just construct the graph, but we don't have to show. So, with a little bit of guessing, we can just hope that this construction is correct. So I think that's exactly what I'm going to do. I'm going to guess this construction and see if it works. First up, read in the size of our graph. And let's just do it like a divide and conquer. We're always saying the value goes 1 forward, right? So we only have to keep track of the middle value. Then we just go print out. So we're just print them out like this. Now let's go divide and conquer. So let's connect x to z. let's make it where this is inclusive and this is exclusive. I'll make it nice. I'll believe. See, does this do what I want? Square it for 10. What went wrong? If x is greater. So we get 2 to 6. So we get 6 to 1. And inside we get here goes to itself. Here we get. Why is this like this? 3, 2, okay. This just goes to itself. Alright, I'm just gonna like hope it works and see how it goes. Always a good strategy. Well, it appears that hoping does not work. We did get to case 7. That's not very promising. We can assume, well, 0 and 1 are just the examples, which are useless. Maybe we should be thinking a bit smarter about this. Let's say we create the loop. But now, every other node goes back to 1. Like so. So we'll take, well, that would take 2 steps to get back to 1. That's not very promising. Only 10 links, 10 links. Stupid. I think this is supposed to trick you. 10 looks like, oh, you know, it should be login, because 2 to the 10 is 1024. It's actually more like a square root decomposition of the top thing. Maybe. Actually, probably not. Because then we need, let's say we had nodes going distance 100. Connect in a cycle of length 10. Now, inside, so we had some nodes connected in a cycle. They're all distance 100 apart. Now inside, you had some nodes connected to the 100. They're all 10 apart. Well, then that could take at most like 20 links, right? And like, what if you even started inside the cycle? inside of here. This node, I was having this like connect backward to here, but this should be connected forward. Maybe just doing that will fix it. A of z is equal to y times 10. Oh, also I did this wrong. Like dumb. Okay. Six. Why is 6 going to 6? Wait, no, 6. 1, okay. Why is the node going to itself? I don't think that should ever be happening. So we'd like to have this connect to here, this to here. Look on the inside. Have 3 go to 1, 2, 3, 4. This goes to 4. 4 should go to 6. Oh wait, no. These are just going to the same spot. Okay. Maybe I did this right. Time for... I don't think there's any penalty for wrong answers. So time for just guesswork number 2. But hopefully correct guesswork. Oh. Exact same. Shoot. We'll just like go into the next almost 1% in. That seems kind of useless, right? Like a wasted opportunity. So what should we do with that instead? Let's say, let's just do this. Let's draw 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 16. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8. Say we had these going to each other. instead. So we start at the middle note. I'm gonna go to the middle on each side, then have these go to the middle on each side. That would work for starting from here to every note and log in. That's for sure. However,
man, I swear last summer was like a dream. Feels like last summer was like a dream. And I'm trying to figure out, I'm just trying to figure out what it means. Yeah, I'm trying to figure out what it means. It's such a tragedy to stay inside on peaceful summer days, but I got nobody calling me, I stay behind the shades. I was thinking about the days, how they weren't even a thing. Wasting hours watching ceilings, clouds passing through the shades. As I wonder why I never said the words I had to say. As I watch the summer slowly fade away with autumn's day. Pink and white and blue and green and warmth that makes me tired. Bright eyes from quiet stares, moments to admire. Now the haze is in my memory, just places that I used to be. I wish I could return, but know that I could never stay. No, I can't call it a home, it's just a stop along the way. And I don't know where I'm going, but it seems I'll be okay. Last summer was like a dream, feels like last summer was like a dream. And I'm trying to figure out, I'm just trying to figure out what it means. Yeah, I'm trying to figure out what it means. Rain don't fall like it used to. The sun gets hotter every year. The people that I know slowly moving away. They're moving towards everything that I have feared. Autumn fades back into the winter. The winter fades back into the spring. When the summer comes around, it will go around again. It will all be just like a dream. Summer is like a dream. Like a dream, like a dream, like a dream. Summer is like a dream.
Well, that sucks. I wonder how much of it was not recording. Shoot. That really sucks. Can't do nothing about it now. So was that like the whole time? Shoot. Why? What made it stop? At least it got to the station. Oh, it was when I was switching tabs. Oh wait. I see. So I was doing that. Shoot. I'll remember that for the future. Oh. Do the finance search idea. How are we going to do this? It'll take 4,000. It'll take like... Say you started from this node. How many would it take? It'll only take like 9, right? 9 steps. 1, 2. 1, 2. Alright, how am I gonna deal with this? This is very annoying. So, I'm just gonna... Look, I'm so mad. I was recording the whole time. Whatever. Okay, what am I going to do? Oh, they sleep. Alright. Well, this is like... How many steps does this take? Cuts it in half. So, this will take like exactly log n, right? From here, it's already cut in half. So it'll take 1. Should take 9 steps. Can I somehow get to here in 1 step? Magically. Alright, let's say... Let's say we mark every other node is turned off. Here, here, Somehow we need to have traveling up and traveling down. So what if we marked nodes alternating? Look, what was it? Still have 3 hours anyway. How long would it take to get? Let's say each paired black node does like the inverse. Well, no, you can't do that. Because what if you sort them?
Perceives all things conjoined. The past, the future, and the present. Everything flows, and all is connected. This eye is not merely seeing reality.
Definitely
it is touching the truth.
Tricky problem. Yet another construct. Why construct?
There is nothing to fear.
Let's instead say that every black and white node can be combined where they point to each other, like this. Now what are the other edges? Oh, one. We'll start off with one, goes halfway. Now you can think of them as a single node.
I see what you mean.
Then we have one going outward, and one going inward. Now you just keep this up. Alright, what if you had every two adjacent are going to each other like that? Now they each have like two more. Right? Yes. So let's say you connect their middle ones to each other. Then, like this. Now these ones still have their middle ones open, so you connect them to each other. Like so. Will this construction work? That's the exact same as. Okay. Get rid of this. Each of these can be a single node with one output, one outward, and one inward. First off, say you got two, so we're gonna go like this. And you got two. know 10 login, we're probably going to use something along the lines of binary search. Let's think about indices and their bit representation. 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0. Why? Alright, 0, 0, 1, 1. Easy, easy. 0, 0, 1, 0, 1, 0. Alright, I'm just writing out the bit representation. Writing out. And now we need to think. How can this help us come up with the graphs? We know it's related to login. Well, let's see, let's look at if we had one, we're able to go to the middle of the others, and they could go to the middle of their friends. They could go to the middle of their friends. Go from, so it's just binary search, but how do you go from a node inside to somewhere on a different range? Well, every one think about, in this case, every single one node, right? Like, there'll be some nodes that only have one direction to go to. Where will the other direction go? Thousand, 10,000, 10. all the nodes unconnected to each other. Okay, now let's say we take the first node, connect it with the arbitrary other one. We take a node and say which distance is farthest away. Two edges. Why do we have exactly two nodes? Alright, what if we think? Okay, let's change our perspective. What if we think of these as the nodes? The edges are the nodes, and the nodes are the edges. That means we print out we're allowed to choose like m nodes. These are the nodes, these are the edges. We're creating nodes between two imaginary edges using each of these. We have n edges. Alright, 0 to 1. Every node will have its cells arranged in a row. Cells are numbered from 1 to n, left to right. Should all cells are empty. You can perform. Choose 3 consecutive cells. Put a coin on each of the 3 cells. I see. Alright, so it starts out empty, I guess. You have an array. You're just allowed to put 3 consecutive coins in a row. Like this group and this group. But then you can also delete 3 consecutive coins in a row. So you could delete like this group if you wanted to get a coin pattern like this. Okay. Simple enough. And it's not cyclic, so it's just like array. Yeah, I'll think about this for a little bit, and then go back to the other one. Because I was not doing too well on that other one. 3 consecutive coins in a row. Well, it'd be better if we can just think of it as... Well, what types of ending states are possible? First, let's just state some properties. First, we know that the number of coins must always be multiple 3. Right? Think about so why is this state possible? Well, we see that between each of the values is a multiple of 3 as well. Is that always the case? Well, 2 coins are either consecutive or they have a multiple of 3 in between. Well, that's not true. That's not true. Like, consider we have 1, 2, 3, 1, 2, 3. Of course, that's just putting down 2 different multiples, but then there's 2 in between here. Alright, consider the first group. That's not a multiple of 3 on the board. They'll have 2, right? That means there'll have to be some deleted in between here and the next one. Is this state possible? I will conjecture no. Because there's not a multiple of 3 in between them. Remember, we have this state. Alright, so I'm gonna make some pretty big for look at like groups of 3 coins on the board. Are there multiples of 3 in between the distances between 2 of them? But then between like a second group right here, there doesn't have to be a multiple of 3. And I'm going to argue this is the only condition for whether it's possible. Is that true? Is this state ever possible? Imagine trying to go in reverse. Put you 3 here. Take out 3 here. Yeah, I think my conjecture is correct. Proving is impossible. But the greatest part of competitive programming is, of course, guessing. So how are we going to solve it then? Well, I'm going to do a dynamic programming where we say dp of I marks that I is the final index that we're marking is on, and j marks which modulo 3 is it. So is it like 0, 1, or 2 in the group? Does that make sense? I think this will work. If it does, if this works, then that means the previous problem is supposed to be easier. So I must be doing something really stupid. So then I just change some stuff. I'm putting the array. Let's do 1 ret is equal to max ret. Now we have to use groups of 3, so the DP of I of 2. Let's see if this works. Shoot, why did we get 10? 10 would be taking all the values, but that's obviously impossible. Oops, I thought not for some reason. Also, this should be myself plus 1. Let's do it like this. Probably need to initialize DP. It's easier just to so let's just use memset at the beginning to set it all I think this is right. Atcoder thinks otherwise. Just one test case, right? Well, I guess we got a few. Dang, I was expecting more than that. 500 squared, what's that? 500 squared? I don't know, maybe it's looking for some ON cube solution? So, are the conditions we listed sufficient or necessary? Sufficient but not necessary, or necessary but not all the conditions. Well, let's try to get 3 values with 1 having 2 in between. First, we'd have to somehow get rid of this. But then if we use multiples of 3, we'd still be stuck with the same in between them. I'm fairly sure it's not possible. Then what else am I missing? Right. What's a case where I cannot write? Oh wait, what about this? 1, 2, 3. Well, that's obviously possible. did we get wrong about the conditions? We need a counter case. So we had multiple in the row. 1, 2, 3, 6, 7, 8, 9.
Choose your fighter. Lightning inspired. Fight.
Alright, I need some way to try to get. Only way to delete is if I build all of these in a row. So empty.
Knockout. You win.
I like this. Nice. Okay, what am I doing wrong? Why are the values so low? Maybe it's time to just brute force some possibilities. Let's do gray. Get some. Get this. Yes. Let's see. So I'm just like trying to brute force some of the different states possible to get an idea of what I'm doing. So this DFS function is just taking the current value of v and then changing it. If does not count, return. Let me do it. 0 equals B1. 0. Give I equal to -1. Let's do this. XOR all of these. Let's see how good this works. Let's do this on size. Let's try 15 to start and see if that runs too slow. So this is multiple of 3, multiples of 3. Wait, oh, here's the counter exam. Wait, hold on. Huh? How is this? This was made. Okay, how this was made. How do you get here to here? There's something wrong with it, I think. They all have to get equal in a row. X row. After you DFS, you're inversing the operations. Where is this one coming from? I guess there is some multiple 1, 2, 3, 4, 5, 6. Let's say delete the middle. Oh. Okay, look at this. So, consider this case. All of them full. Now, we remove 6 from here. Now, we can add 3 here. What can you see about this? These 3 in the middle here. Obviously, this is like a polygon conjecture, because the first 3 have a space of 1 in between, but this is obviously possible to make since I just made it. But we can think about it like parentheses. See, once you delete the middle and the end, then you can do whatever you want on the inside, as long as the outside. So like, imagine you have a range, right? If you have like the final three on the outside were connected, then you can say you can do whatever you want on the inside. All that matters is that the inside is a multiple of 3. This should lead us to do some sort of range thinking. I think this is an idea. Alright, so it's like a range DP where you look at the insides, since this can be done completely independent of the outside. I think this is right. So let's get rid of this. Let's try range it. I think this one. Typical AGP setup. Oops. As you can see, I like anything but constructive more than constructive. Alright, let's see. Will our idea work? So if So first off, we can have DB of IJ equal max. Alright, because you could just be using a range inside without any rules on the outside. If minus 3, so whatever I like having kind of all the constants as variable. Alright, there are a few cases. Alright, the second case is if okay, we could just add 3 values on the outside. Let's see. This is just adding like 3 values at the end. Now, multiple. Okay. We can say Alright, here we need to do where there's one on this side and two on this side. Do we need this case? I don't think we need this case. What we need to do then is add like two separate parentheses groups, right? That are simple range. So let's go back to our this. Make sure it works. Alright, so you may be wondering why you don't ever have to deal with the case of 3 in a row. Oops. Well, that should be because both of these cases cover that in those exactly 3. What's happening now? This one. Okay, this one. Okay, what's happening? See ya. Okay. So I'm just like putting the outputs to see where it's going. In this simple case, it should have nothing going wrong. That's alright. 2, 3. 2, 3 is 10. How is 2, 3 10? How is it even getting any answer for 2, 3? 1, 2, 3. How? Let me see. getting added here. Is it for some reason initialized at that? That wouldn't make any logical sense. So we'll print here if it thinks that this is multiple 3. Wait. Oops, let's see. As always, it's because I'm lazy. Alright, 9, good. 7, how are you getting 7? Alright, 3 to 5 is 3, sure. Wait, 0, 1, 2, 3, 4, 5, yeah, 3. 2 to 5. Still 3, sure. What is the maximum from? So the optimal stage we're picking here and here. So what's the maximum memory value? 0 of 1 to 3. 1 to 3 is 1. How? Please tell me. Alright, first off is some submarine. 2, 2, 1, 1. 3, 3. All of those are 0. What about 1, 2? 1, 2. 2, 3. Both 0. 1, 3 is 1. How? Probably because I did this like an idiot. Okay, finally 6. This should be right. It's just like creating parentheses. How? Please don't. Seriously? All WA? Why? What now? Look at our DFS. See, the parentheses here would have this as a group separate from this. And how does this exist? There are only 1, 2, 3, 4, 5 ones. How is that even possible? always adding and removing 3 at a time. I see 11. Zero to end. That's fine. Idiot. Okay. Why am I being so dumb today? Why am I so dumb every day? Let's look at this. Parenthesis group. This is like inner parenthesis, outer parenthesis. Huh. Well, that's... We're not accounting for this case, are we? Here's what we're gonna do. We're gonna generalize this. The two in the parentheses can be like here, and then split it into 2 groups of inner parentheses. So if J minus this one is like K. So we're going to have 1 on the outside. Plus A plus A plus something like this. Let's try this. Alright, I think this will work. This has to count for our case, right? What other case could we be missing? Oh, it's looking good. Looking good. And are we gonna get it? Yo, let's go. Finally. Our first solve. Well, we're not doing too bad, I guess. How many people are doing this? Alright, it seems many more people got A than B, which means I must be overcomplicating A. What could I be doing wrong? Well, so that I could get B, but not A. Well, also, just for fun, first let's read C. But obviously, A should be easy, so we'll go back to B. So we'll go back to B. And a super hit. Why is this missing? Oh, it's using the rankings as inspiration. Alright, let's look at the block. What were the official rankings? Dang, a lot of people getting 4 problems. It appears no one just got B and D. Wait, no, that just was farther down. Not too many people only got B. Wait, well, what am I trying to get? I'm trying to get just B and C. It seems like basically no one. Block game. There's a sequence of cells that extends infinitely to both directions. You and Snook play the following game. The judge chooses a string. And, well, let's go back to the original stuff. The judge chooses a string T consisting of B and S, BS, called churn string, and show it to both players. First, Snook stands on one of the cells.
I'll always remember the time we spent together.
That letter is B. Neither other block nor Snook. The ith letter, T is B. It is your turn. You choose a cell that contains neither other blocks nor Snook. And put a block on that cell.
Hush now.
Wait, what's the goal of the game? Oh,
I got black, I got white, what you want? Hop outside a ghost and hop up in a
alright, so Snook is
I know I'm about to
completely
blow,
blocked.
I
Then
ain't done. They try to take my flow, I take
it's
the
like the 2D version of
I know
the
that I'm
Angels.
gone. They see me blowing up, now they say they want some. I got two
Angel
twins,
versus
I
Devil.
see two dancer. I see two
Where you
twins,
try
I
to
see them
block
on
the
the
game.
band. And I got two thick thoughts, wanna link the I got red, I got blue.
So then
what you
B or
want?
S
The Chanel
represents
Balenciaga,
whether it's
Louis and Vuitton.
your
You know I
turn
got
or
the
Snook's
funny
turn.
title when I hit Milan. I needed me a diet rider, I
count.
need me the one. I started from the bottom, you can
For the
see the way
question
I
marks,
done. I want all
if
the
you fill
diamonds,
those
I
in,
want that
how
shit
many
the way it's
different,
done. The odds
like,
they tryna
move
lie me 'cause
orderings
they hate this place
will
I'm
allow
from.
Snook
But
to
some
win.
niggas don't know me, they just know the place I'm from. I got lots of shorties tryna pull it to my place. But you ain't want me lashes, so just get up in my face. They all up in my inbox, so I
So
know
first
they
off,
wanna taste. I know they want my downfall, a nigga, are you lazy?
if you think
I
about
got
Snook's,
black, I
so
got
think
white,
about
what you want? Hop Hop outside a ghost and hop up in a fan. I know I'm about to blow. Whoa, whoa, I ain't done. They try to take my floor, I take they ass for ransom. I know that I'm gone. They see me blowing up, now they say they want some. I got 2 twin Glocks, 3 dance I see 2 twin ops, even on the band. And I got 2 thick dots, wanna link the gang. I got black, I got white, what you want? Hop outside a ghost and hop up in a fan. I know I'm about to blow. Whoa, whoa, I ain't done. They try to take my floor, I take they ass for ransom. I know that I'm gone. They see me blowing up, now they say they want some. I got 2 twin Glocks, 3 dance
So consider you have this at long range, and Snook starts here. So for let's represent it by a dot. So like for all the Snook turns before the first block, it's useless to move because it's infinitely long. So it's like doesn't matter. Imagine the first block. The optimal place will always be right next to Snook. It doesn't matter right or left since it's symmetric. So let's say it's on the left. Let's just Snook over. Well now, what is he gonna do on the next S's? Well, he wants to be as far away from the block as possible, right? Well... yeah, he wants to be as far away as possible. So go 2, 3, 1, 2. So it'll be like here, right? Now imagine you block on the left again. Well then, it's just like cutting off over here. You're restarting all over. So you're always going to put the block on the right. Now, Snook will try to get as close to the middle as possible. Why the middle? Because then it's, once again, sort of like a log binary search divide and conquer like thing. Where if you block here, then he just has this game. If you block here, then he just has this game. So he wants to be as close to the middle as possible. So what can you say? Well, think about all the blocks in the string and the distances between them. First distance, x. So the first distance marks there's x. Oh, well, let's say you start out with some count, with some variable that's like the distance you have to play, and it starts out as infinity. Now, Snook. On the first block, nothing happens. On the second block, D, let's say the difference between them is like x. D will become min of like D over 2. D should be ceiling, I think. So this xi, D represents the distances on the array. This is like in the string. Let's mark in the array as their x instead. X and if they're like xis is here, then D will become min of di over 2 x. And you're seeing once you have all the b's in the string, you need to just know, is it possible for D to become 1? Because if D equals 1, Snook loses. Otherwise, obviously, because d becomes at largest d over 2, we know that we only need at most log n b's for Snoop to guarantee to lose, right? So this means, imagine the question marks. We can just use basic combinatorics to count all the ways that there are greater than log n b's, right? Now think about the ways that there are. Now think about the remaining ways. We'll have to do some sort of dp. It's like a dp of I. Number of cells put down. J, this is n, log n, is equal to a data structure, a range data structure. Well, like if we could just do dp of I, j, d, that'd be easy, but this would be O n squared, obviously. So the question becomes, how to count the number of ways to put only log n b's down, or the distance, and see if the distance becomes 1. we adjust, we could get A. It shouldn't be this hard. It's just a basic constructive. What is D? I'm just curious. And people, and decay. Layer 1, layer 2. Alright. I don't like that one. That's like a math DP thing. This one seems more fun. First, I should be solving this since it should be easier. Any ideas? Any ideas? Alright, so obviously we need a jump like in powers of 2. And like decreasing powers of 2. But also, how do we get to the where we can jump to the largest like power of 2? of cycles in like a size as it powers it to. Well, basically, you're always allowed to go in a circle, right? But every other node, you're allowed to jump one to the left. Every third node, you're allowed to jump backward a greater amount. How do you get between 10 nodes quickly? No, I'm just gonna try coding this. I have no clue if it works. But like, I need more ideas. Well, I need to get something that works. So how do you describe each of these? Alright, so every other one goes backward, right? There's one here. Otherwise. So it's just the lowest bit set is how far back it goes. All you need is Alright, I minus 5 negative. So this gets the highest. This gets the smallest power of 2. What is that? You sure you're doing this right? So this goes back 1. This goes forward. What about in this construction? This guy is never even used. Twice. Let's see. What should we do? Let's not use this cycle idea. Let's something else.
Man, I swear last summer was like a dream. Feels like last summer was like a dream. And I'm trying to figure out, I'm just trying to figure out what it means. Yeah, I'm trying to figure out what it means. It's such a tragedy to stay inside on peaceful summer days. But I got nobody calling me, I stay behind the shades. I was thinking about the days, how they weren't even a thing. Wasting hours watching ceilings, clouds passing through the shades. As I wonder why I never said the words I had to say. As I watch the summer slowly fade away with autumn's day. Pink and white and blue and green and warmth that makes me tired. Bright eyes from quiet stares, moments to admire. Now the haze is in my memory, just places that I used to be. I wish I could return, but know that I could never stay. No, I can't call it a home, it's just a stop along the way. And I don't know where I'm going, but it seems I'll be okay. Last summer was like a dream, feels like last summer was like a dream. And I'm trying to figure out, I'm just trying to figure out what it means. Yeah, I'm trying to figure out what it means. Rain don't fall like it used to. The sun gets hotter every year. The people that I know slowly moving away. They're moving towards everything that I have feared. Autumn fades back into the winter. The winter fades back into the spring. When the summer comes around, it will go around again. It will all be just like a dream. Summer is like a dream. Like a dream, like a dream, like a dream. Summer is like a dream.
She's a goddess, a wish from a star in my heart. Oh, yeah.
Obviously, the problem with this DP is the D. Is there a way to get rid of that?
All things conjoined, the past, the future, and the present. Everything flows, and all is connected. This eye is not merely seeing reality, it is touching the truth.
put down JBs, William Oops login. Obviously this login has to be important. What can we do with the login? We're able to do something like a divide and conquer. Any ideas? Let's think about the shop. Yeah, it is Sweet Rhythms. Look, I'm so stuck. I'm not doing very good. This guy got D, this guy got C. Why can't I get A? All these people got A real fast. They play a turn-based game. Alright. We need to think. This one is a math problem, right? So it's like a... What's the probability the ith player wins? Alright. So you have like a K items, right? So you can do N and K are small, so you can do some sort of DP. So think about a single round. Well, okay. Think about it like this. We're going to solve for each person. We're gonna do this. DP. Well, let me explain my thought process. So to calculate for person I how many it takes when there are like n people for k, what are the things that matters? Well, the probability for person I depends on how many people are before it, how many people are after it, and how many people are after him, right? Because that affects the probability. And then the number of items that are left that haven't been chosen. Well, that means we should be able to store dp of n, k, I as a state. So why are we also storing I as a state? Well, think about it. If you change, for example, if person 1 selects it, is able to get a gift, then now you can think of it as the index changing. Also, think about it like this. let's say the next person. Now for our transitions, we only have to think about when someone selects a gift, it'll be taken out, right? Let's say person J after I selects a gift, right? You have 1, 2, I, J, and -1. Person J gets a gift. Well then now, you're basically doing DP, where now the starting value is here. Your index is rotated. Does that make sense? Like your index is rotated. So you shift the index and do DP of like the k minus 1, like k minus 1 and -1, I rotated. Okay. I think I got this. It appears that I can only do the straightforward DP. But yeah, I think I got B, and I think I got B, and I think I just got D. So let's see how that goes. Wait, what am I doing? All we have, so what do we need? We needed 3 states. Max in is most 40. Alright, so okay. So then, what is the order of states? We need a process. We need a process. Wait, hold on. Do we actually need n and k as separate states? We don't, right? Because, like, whenever k is subtracted, which means the item is taken out. Oh, wait. Yeah, but we don't need k as a state. I don't know why we have it. I don't know why maxin is so small. It should be O(n) squared, cube, something. I don't know. So wait, our state is how many things are left? What index are we? First off, we need to calculate the base state, which is there is a single item. So like k equals 1. K equals 1. So what is the, if there's a single item and we have n people trying to get it, and we are the ith person. What's the probability that I ends up getting it? Well, it's like, you can think of it as, so think about how many cycles will it be where everybody misses it. Well, it'd have to be one item left, so they're guessing like k minus 1 over k to the n. So it'd be the sum of x equals 0, k minus 1 over power of I minus 1 times 1 over k. Right? Well, this term can just be separate and be taken outside of the summation. And the summation, obviously, is just the basic, like, 1 over 1 minus, what's it called? A geometric series. And that is the probability that the ith person wins. First off, we need a Alright, this is just a binary exponentiation basis. First off, let's put the base cases in place with our formula. We'll say k is an PP of how many items are left. 1 and xi equal to I we should just get the inverse of k out. Just calculate small inverses ahead of time. So now this should be IB of k. this is it. Well, let's do it. We should be doing it. We need to calculate the probability that your guy is the guy that gets it every single time. So let's do this instead. So first off, copy of I, J is equal to, what's the probability that your guy gets it? K minus I. How does this account for when the first player picks the first move? X to the J. Well, X would be 0, right? So X to the J would be 0 only when J is 0. I see. Yeah, okay. It should be I times IV, okay. So, come on. Alright. This should be the base case, which is this, you are eighth person is supposed to otherwise, well, okay, let's make this its own function. Because we'll need to calculate this one. So basically, we need to be able to pick if the jth person is to pick the first value when there's I left. So let's just compute that. So it basically looks like this. F of IJ is equal to this. you can also have another person pick first, right? So what happens for them? Oh, where does it go? 0. So now, remember what I said. You have to imagine when that other guy picks first. Like J picks first. Now you have to imagine you're left with only the people after J. The re-index with this guy being 0, 1, 2. So you have to re-index I and get the smaller for I minus 1. Re-index. What's the difference between wait. How many people are left? There's only one present left. There's only n minus. Well, that's basically done. There's only n minus k minus I people left, because all the other people already picked. Should be this. IL. DP. So when they're what are they called? Like items left. There are n minus k minus I people left, because the first k minus I people already chose a present, but your guy hasn't chosen a present yet. So you're saying your guy could choose a present. Otherwise, this guy could choose a present. You take him out of the order, re-index, where the first guy becomes number 0. And then what's the DP of when you have one less item? And then what's the rotate? You have to do int x equal to a minus. Let's see. fun actually. And now we just output. See ya. Oh wait, you also have to do what? No, this should be TP. K. Y. How is this do? Long ones. That'd be another problem. I'm still getting the wrong answer. Why? I think I have the right idea. I'm pretty confident in my idea. J minus L minus 1. I need to make sure that sum of f of ij equals 1. Otherwise, I'm calculating incorrect. Okay, that looks good. What is this one? The process. That looks good. I'm pretty confident we're calculating this right. Oh, it's the same intro as that Bruno Mars one. Let's see, we're getting close to finished with this. N minus K minus I. Give me a ij, what f of ij? What am I doing? First person, choose probability function. First off, let's see. Sorry. This should not be equal to 1, right? This is equal to 1, then I did something wrong. first person guarantees to win. So what am I calculating? F of 1, 0 is equal to 1 over 2, 1 half, times 1 half to the power of 0. So I'm saying this is 1 half times
Choose your fighter. Lightning inspired. Fight.
Alright, this should be okay. Items IVAK. This is all like independent. Just 1 half. That seems kind of oh, wait.
Knockout. You win.
He hasn't chosen uniformly. Oh. I did not read that. I mean, it's not that hard to deal with. But it's still annoying. Alright, basically, we just have to add one more state, which is how many items have you not guessed? Or how many items have you guessed? Why would they add such pain? It's basically the exact same DP, except figure it out. I'll code exact same DP, except for you have one more state. That's how many times have you guessed? So whenever you guess, you have to. What that means is like, if L, you could have dp of ij L equal to dp of ij L plus 1. dp of ij L equal to ij. I'm pretty sure I have this idea right, but that just seems like I can't. I just this. Right, it's problem A. I already coded B. I know D. Why can't I solve A? Alright, 2 outgoing inputs. 2 outgoing inputs. 1, 2. We can get to any page, any other page, at most any. Well, think about 20 links. Alright, think about this construction. 2 nodes at the top. Then you have 2 nodes at the top. They form a cycle. Now each of them also goes outward to one of these. Wait. Wait. Looks like this. Each of these splits to a section like this. this idea? Well, as you can see, it resembles, yet again, another sort of divide and conquer idea. Where I'm using cycles of size 3. However, I doubt this will take only 10 jumps. Let's think about first the height of this tree. Well, the worst height is like if you go from here to you go down a level plus 1, down a level plus 1. How many levels are there? Well, you can think of there's like 1/2. Think of each pair of nodes as a single node. There's like in that case, there's n/2 group nodes, right? There should be log n of n/2 group nodes. So just going from the bottom to the top will take 2 times that. This will get any place to any other place in almost 20 minutes. First off, let's make all these packages not go up one level, but go up all the way to the top. That way, in at most 2 boosts, we can go to the top, and then start our binary search like that. Just to get to the bottom of the tree. Just to get to the bottom of the tree, it takes a minute. Each level could take an extra move. building a tree structure, which is kind of nice because it has that like log n depth. But one problem is that it's like not symmetric. Or is there a way to make this sort of idea symmetric? Or like let's think about what Atcoder does here. Well, these are just subtracting powers of 2. And these are adding powers of 2. Subtracting powers of 2 and adding powers of 2. You can't really like do that though. It's like go back to our very first idea. Why did this not work? Had jumps of like powers of 2. So, what did I code right or wrong? Here I did a y%. Is that the right way to go about it? Should I have done instead a backwards edge? can we make this idea better? Well, we need a healthy balance of how often it goes back up to the root and how often it just is a single node that splits into two subtracks. Either way, we'd have to do it in hours more. I don't think an idea like this will work, even if it's a kind of cool looking thing. I'm getting pretty stuck at this point. What can I do? What can I do? I need a new idea. Think of something new. What is something you haven't tried? Two things. What is important about two things? Well, two links. What is this idea basically doing? Well, before we start to move back to the edge, before we said just to have one that goes back to the root every time, we were like having cycles of 3 that were interlocking with each other, right? Let's try to take this interlocking cycles idea further. Alright, so it's kind of cool that like you have cycles and they're like kind of all connected. cycles of like different degrees and powers. Does this help us? Let's think. I still think it'll like take 2 times longer. How is it possible to do less than 20? 2 minutes. Well, we definitely ain't gonna code it in time. But is this kind of idea right? It has to be something with cycles, right? Like, how would it not be symmetric? What if you wanted to go to the node right behind it? Is that possible? In login steps, it does not look like it, right? Alright, I basically give up. I'm gonna look at that tutorial. Solution may be hard to notice, but it's very simple. Consider the indexes of pages modulo n. X, add 2 links to 2x and 2x plus 1. Dang. Alright, let's think about that. So that's literally just creating the binary tree. But then for the nodes that go off, instead of like bringing it back to the beginning, X. Oh, that's smart. Ugh, that's so simple. Ugh, I need to do something. Alright, let's look at C editorial, because I'm also
Always
curious.
remember the time we spent
Was I
together.
anywhere close? Oh. Given string, how to check the winner? 0 infinity.
Hush now.
Okay, that's exactly what I said. Only if the min.
I got black, I got white, what you want? Hop outside a ghost and hop up in a phantom. I know I'm about to blow, whoa, whoa, I ain't done. They try to take my flow, I take the after
Well, I had like most of the observations according to this editorial. But they're doing something smarter here. Where they're saying instead of like thinking about it continuously, just think about the current transition. The min of the transitions, when divided by the power of 2, the times left has to be less than d. So that makes it. I think that makes sense. Oh yeah. Dang. Dang, I missed. How did I not get there? So simple. Oh. I'll say I was like a kinda close, I guess. And then D. I'm pretty confident my idea is correct. And I was just too lazy to code it. Oh well. But, as I can see yet again, Atcoder Grammar Contest, not too easy. But the solutions were all pretty nice. Oh, that's all for today. Adios.